Hello my dear students, welcome to my physics class. Our today's topic is simple harmonic motion. Let's start now. This is the velocity of the particle executing simple harmonic motion. Here V is equal to omega root over a square minus s square. From this equation, it is seen that velocity of the particle executing simple harmonic motion depends on its displacement x. That is, velocity of the particle depends on displacement. That is, velocity of the particle varies with displacement. When x is equal to 0, the particle crosses the middle equilibrium position. So, we can write this equation V is equal to omega root over a square minus x means 0 square. This is equal to omega a, and this is the maximum value of velocity. That is, maximum value of velocity is omega a, and we will get the maximum value of V at equilibrium position. When x is equal to 0, we will get the maximum value of velocity. Therefore, V max, that is maximum velocity, is equal to omega a. When x is equal to a, that is x is equal to amplitude, maximum displacement, the particle reaches at one end point. And in this case, velocity V is equal to omega root over a square minus x square means a square. So, V is equal to omega root over a square minus a square is equal to 0. And this is the minimum value of velocity V. Therefore, V minimum is equal to 0. So, we will get the maximum value of V at equilibrium position, and we will get the minimum value at maximum displacement A. So, at maximum displacement, velocity of the particle is 0. Now, acceleration. Displacement of a particle executing simple harmonic motion is x is equal to a sin omega t plus del, and velocity V is equal to omega a cos omega t plus del. We know acceleration a is equal to d dt of V, that is differentiation of velocity with respect to time. So, d dt V means omega a cos omega t plus del. Now, if we differentiate this omega a cos omega t, if we differentiate cos theta, then it will be sin theta, minus sin theta. So, we can write this minus omega square a sin omega t plus del. Here omega a cos omega t plus del means omega a sin omega t plus del. If we differentiate this omega t, then we will get omega. So, it is omega into omega minus omega square a sin omega t plus del, or a is equal to minus omega square x. A is equal to minus omega square x. That is a sin omega t plus del. Here a sin omega t plus del is equal to x. Therefore, a is equal to minus omega square x. From this equation, it is seen that acceleration of a particle executing simple harmonic motion depends on its displacement x. That is, acceleration a depends on displacement. Acceleration of a particle executing simple harmonic motion is a is equal to minus omega square x. And we know acceleration depends on displacement x. When x is equal to 0, the particle crosses middle equilibrium position. And in this situation, a is equal to 0. Here x 0 means a is equal to 0. And this is the minimum value of a. So, a minimum is equal to 0. That is, the acceleration is minimum at equilibrium position. And we know at equilibrium position, velocity is maximum. That is, at equilibrium position, acceleration minimum, but velocity is maximum. When x is equal to a, the particle reaches at 1 in, that is maximum displacement. At maximum displacement, then a is equal to minus omega square into a, and this is the maximum value of acceleration. And here negative sign indicates the acceleration is opposite to the displacement. Therefore, a max, that is maximum acceleration, is equal to omega square x. The value of maximum value of acceleration is omega square a. Here negative sign indicates acceleration is opposite to the displacement. So its maximum value is only omega square a. Here value is omega square a. This is the maximum value. So at maximum displacement, acceleration is maximum, but at maximum displacement, velocity is 0. So when acceleration is minimum, velocity is maximum, and when acceleration is maximum, velocity is minimum. Maximum displacement, velocity and acceleration already we have calculated. Here x max is equal to maximum displacement. We know maximum displacement of the particle is known as amplitude. So x max is equal to amplitude a, and v max is equal to omega a, and a max, maximum acceleration, is equal to omega square a. So maximum displacement a, maximum velocity omega a, and maximum acceleration omega square a. Now mathematical problem 1. The maximum velocity of a particle executing simple harmonic motion is 6.24 centimeter per second. If the amplitude of the particle is 3 centimeter, what is its time period? Here maximum velocity of the particle is given, and this is 6.24 centimeter per second, and the amplitude of the particle is 3 centimeter, and we have to determine its time period. Now solution. Here amplitude a is equal to 3 centimeter, and if we convert it in meter, then it is 0.03 meter, and maximum velocity is given 6.24 centimeter per second, and it is 0.0624 meter per second from centimeter to meter. Time period t is equal to what? We know maximum velocity Vmax is equal to omega a, or omega is equal to Vmax divided by a. So omega is equal to maximum velocity 0.0624 divided by 0.03, and this is equal to 2.08 radian per second. This is the angular frequency. Angular frequency omega is equal to 2.08 radian per second. Again, time period t is equal to twice pi divided by omega. We know time period t is equal to twice pi divided by omega. Already we have determined the value of omega. So time period twice pi divided by 2.08, the value of omega, and after calculation it is 3 seconds. This is the time period of the particle executing simple harmonic motion, and its maximum velocity is 6.24 centimeter per second, and its amplitude is 3 centimeter, and time period is 3 seconds. 2. The amplitude and frequency of a particle executing simple harmonic motion are 0.01 meter and 12 hertz respectively. Calculates its velocity at a displacement of 0.005 meter. Here amplitude of the particle is 0.01 meter and frequency of the particle is 12 hertz. We have to calculate the velocity at displacement 0.005 meter. We know velocity depends on displacement, so we have to determine the velocity at this displacement, and here amplitude and frequency are given. Now solution. Here amplitude A is equal to 0.01 meter, frequency 12 hertz, and displacement 0.005 meter. We have to determine the velocity at this displacement. Velocity is equal to what? And we know omega is equal to twice pi f, and this is equal to twice pi into frequency 12 hertz. So this is 75.398 radian per second. This is the value of omega. Again, we know velocity v is equal to omega root over a square minus x square. Now putting the value of omega a and x, here omega is equal to 75.398. Already we have determined it, and the value of a is equal to 0.01 and value of x is equal to 0.005 meter. Now after calculation it is 0.65 meter per second. So the velocity of the particle at displacement 0.005 meter is 0.65 meter per second. This is the velocity at this displacement.